Hello there, folks. Hey, Joe Wazoo here. Hey, today I'm going to talk about a simple application to create an on-tick timer. So in this example, let's say that we've got something that we want to run for so many seconds or minutes or whatever, but we'll pick on seconds for this. And how could we create a function that does such a thing? So in this case, if I go over to the left and go to programs on the left side, and I've got a program called an OnTick Timer. And you can see I've got timer 1, 2, 3, and 4, and 5, but we're just going to look at number 1 for now. And if we look at this code for this particular function, I want you to notice that in here there is a ticker that is inside this folder. There's also a done thing. So if I go over to the right side, and if I expand my OnTick Timer 1 there, you can see that inside this folder there's a tag called ticker, done, and account. Okay, so this program is going to be called once a second or on tick, and the first time it calls, the ticker is going to be 0. It's going to take the ticker and add +1, so that's going to continually add up. Then it says if the ticker becomes greater than or equal to some tag called delay, then it will set the done bit to a 1. It will reset the ticker, and it will then return the done bit. And you might ask, what do you mean by return? Well, look up here in the prototype section. If I hit the edit button here, I'm actually running this program as a function, kind of a function block, if you will. I can send up to 6 parameters into a function. In this case, I'm only sending a parameter integer value called delay, and it's the first one. And then I'm going to return a integer. I'm actually returning a flag tag, which is a boolean, but it's part of the integer family. I don't have a choice for an integer here, so I'm sorry, I don't have a choice for a boolean, so it's part of the integer family. So that's what it's going to return. So if you look here at the structure, let's see if I get my pointer to do it. If you look right here at the structure here, it's the program name and then parentheses, some tag called integer delay there. So that is the program. Now, where I'm going to call this is actually in a function, a switch case, which I'll get to later. But if I look at this, the way I call this, maybe I should do this a little different here. Let me think here. Well, I've got a program here called main loop. And in the main loop, let me get rid of this section here real quick. So if I wanted to call that program that we have there, and I want to create, let's say, let's call this a test done. Watch this. I type test done. I'm going to do equals space. I'm going to go over to the right side. I'm going to grab this program. I'm going to drag it here. Now notice that my cursor is in between the parentheses. That's because that needs that delay tag that I need to send to that function block. So I go to the right side, and I'm going to grab one of these delays I have here. And look, I'm going to drag this guy right here. I'm looking at that black line. When I see the black line is in between the parentheses, I'll go ahead and drop it right there. And then I'll put a semicolon out to the end here. Okay. Now, according to this program, the test done bit should go on when delay 1 is met. And right now, I am running this program, in this case, this main loop. I'll show you in a second. Notice the yellow diamond here. I'm going to go ahead and compile. I do not have a tag called test done. So I'm going to hit this button here. Crimson's going to bark at me. I'm going to make it, that's going to be a flag tag right there. I'll say yes to that. Okay, I think that looks good. All right, now let's go test this. I'm going to go over here to my display pages. I'll go over here. I'm going to grab this test done, and I'm going to drag it out here like this. And I'll make this guy be a little bigger, and I'll make it to be data entry. All right, let's go ahead and download this to our screen. Let's see what happens here. Okay, instantly you can see it's already on. Now it's on because the delay here is set to 0. So if I put the delay in, if I click here, change this to say 10, for instance, it's already on, but I need a way to reset this. So if I go ahead and reset this, okay, it tripped already on. What we need to do is we need to monitor the status of our ticker value there. So I'm going to cheat a little bit. I'm going to go here and I'm going to grab the ticker out here like this. I'll put this guy in. I'm going to make this, well, I don't even make it data entry. And I might take this and put it out there and make it the data entry. All right, let's try this. Okay, you can instantly see it's already counting. It's going to count to 10. And when 10 gets set, this is going to reset. Look, there it is. It's tripped. And you can see it's going to continue on. Now, it won't reset this again until it gets to 10. Now, if I don't turn it off, it's going to stay on. So when I hit to the end here, I really need a way to turn this guy off like that. Well, I need to turn this one off here. I did it too late. Okay, let's try here. Turn that off. There, it's off. When it hits number 10, it'll trip on. So that's just one example of that. Now, let me go ahead and remove that from my main code. I'm going to get rid of this thing we just did. And instead, I'm going to run this program called switch case logic. Let me go and translate that. I'm going to clean up our page a little bit. We'll get rid of this stuff here. All right. So I've got this other program called switch case logic, and I'm using a function, the switch case function, which is a really neat tool because I can use a tag in here, and based on what number that tag is or what case it is, what value that is, will determine which part of the code I run. So in this case, I've got a task number that can go between 1, 2, 3, 4, and 5, and then that's it. Yeah, 1, 2, 3, 4, and 5. And the way this thing works is when it goes into case 1, if the delay is greater than 0, means there's some delay, it's going to start to call that same program we just used. Once it gets done, then it says, okay, if it's done and the task number is still at step 1, then it'll do some clearing of the data and it'll go to step 2 and then proceeds through to step 3, 4, and 5. But the catch is I have to set the first case into 1 to get this to run. You'll see when I go download this, it'll be 0 by default. It won't execute this code. Then once it stays, I put it into the 1 mode, it's going to basically go through case 1 through 5. When it gets with number 5, it's going to start all over again and kick back to task number 1. So let's go ahead and download this to the screen and let's demonstrate this. All right, so here we are. One of the neat things about this demo as well is I'm doing a kind of a flip-flop thing down here just to make sure the HMI is not locked up here. If I reset everything to 0, I don't know why that one didn't reset. Everything should go, that's weird. I wonder why it didn't reset, but these are all set up here. If I generate delays, there you go. Okay, all right. So if I turn the task number to number 1, it's going to run through the first time, but you're going to see that all of the numbers here that went through it, then once again the first time through, it generated a random generator here. And now this one's going to count up to 7, boom, before it moves on to step number 2, which you're seeing here. And you can see the number right here change to, it'll go to number 3 here when this gets to 10. Boom, there you go. Now I'm in step 3. And the beauty of this, here's step 4. It's really a neat way to control what happens at each step of your program by using this case switch statement. And I'm only running this program, I'm running all this code. The main loop toggles this toggle main. This is what's just turning on that LED down below. And then this is the case statement that's doing all the code. It's all being run here in the main loop. And then main loop is being executed, I believe, is it here? Yeah, over here at pages in OnTick. I'm doing everything in OnTick or once a second. And that's the kind of a simple way, team, to create a simple OnTick timer in 1 second increments. And then I'm also using the switch case statements to run through my logic here. So you can see that as this jumps through, it shows where it's at. And then, of course, the only way to stop it now is to put this into mode 0, and that will cause the break or case statement to stop, and that stops all the logic right away. Once I put this back into state number 1, It starts up, goes into number 2. Here you see it going through. Number 4 will take up to 10 seconds. And then number 5 is 5 seconds. Once that gets done there, it'll start all over back at number 1. There you go. Anyway, pretty neat demo. If you want to copy this database, it's called the Time Loop database. I have it currently written for a C3RK, but you can use it on any Redline HMI. Hey, thanks a lot, folks. Have a great day.